Greetings. This is the voiceover for the practice, the final practice final. I can spit it out. What you're going to see here is that some of these problems look familiar. I've changed the values. We've seen these kind of over and over again. Student taking a test, the physics majors and the minorities, but I've changed the values to. There's just so many different problems that I can use with the test bank. Anyways, let's get started. A test consists of 10 true false questions. To pass the test, the student must answer at least nine. Well, at least if you get 10 questions and you have to get at least nine, that means you have to get nine or 10. So, a couple of ways of doing it. The easiest way, since you're finding the back end, what I'm using is the complement rule. All right, the complement of 9 or 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm using binomial cumulative. All right, but remembering that once I find that, I'm going to subtract that from 1 to find the complement of 0, 1, 2, 3, 4, 5, 6, 7, 8, which is what I'm looking for, 9 or 10. So 10 trials, probability of a true false is 0.5 if you're guessing. I'm telling the calculator to stop after it adds the probability of 8. It takes the probability of 0. It always starts at 0, adds the probability of 1, true false question, plus 2, plus 3, plus 4, all the way up to and including 8 true false questions correct. And then you take that, you subtract it from 1, and you find what you're looking for, the probability of 9 or 10. Not too happy about the fact that this is so close, but your calculator was spot on, 0.111. I wouldn't have this on the exam. I'm not trying to. Well, if you did it correctly. And here the important thing is you see all the answers out to three decimal places. So what I would do is, even prior to doing the problem, or at least when you get the answer, make sure you go to mode and you set your calculator to three decimal places so there's no discrepancies. Here I'm seeing here again the answers all the three places. A certain college, 33% of the physics majors are ethnic minorities. If 10 students are selected at random, what's the probability that no more than six? Six is good, but seven, eight, nine, or 10 is no good. So, unlike the first one, you're not finding the back end, you're finding the front end. Probability of zero, ethnic minority, one, plus two, plus three, plus four, plus five, plus six. So, it's a straight out cumulative, but no subtraction. You're finding the front end. So 10 trials, probability of a success, getting an ethnic minority, 0.33. You're telling the calculator to stop after it has the probability of 6. No more than 6. 6 is good. 7, 8, 9, or 10 are no good. Straight out binomial cumulative. Brand of coffee in a certain brand name of a certain chain of coffee shops has a 48% recognition rate. An executive from the company wants to verify the recognition rate, and he's interested in opening a coffee shop. He selects 9 Coffleton residents. Find a probability of exactly 4. Well, this is the easiest one. It's a binomial PDF. You're asked to find exactly, all right, exactly 2 or exactly 3, or in this case, exactly 4. It's a PDF, not a CDF. You're not cumulative. You're not adding a whole bunch. You're just, hey, probability of exactly 4. PDF. 9 trials. Probability of someone recognizing the coffee shop is 0.48. And you want exactly 4. All right, your X value is 4, and there it is, 0.254. Notice spot on to the letter B. Here I'm asking to find the area of the shaded region. All right, now area and probability are one and the same. Your lower limit, here it is, negative 1.8, negative 1.88. Make sure when you're putting in this negative sign, you're using the white key below the number 3. You're not using the gray key on that right-hand column. If you use that, it'll give you an error message. So there's your lower limit, negative 1.88. Your upper limit is all the way out to positive 1.88. It's a standard normal. Mean is 0. Standard deviation is 1. And there's your answer, 0.9399. You're off by 1/10,000th. But notice there's nothing even close to that, so you can live with 1/10,000th off. All right, you're looking for the z-score. Now there's that z-score right there. All right, it's to the right of the mean. Now if the mean is 0, this represents 0, and you're to the right of it where this question mark is, you obviously know it's a positive value, so this makes no sense. All right, now the area that's associated with this value here, this z value that you're looking for, which is the same as an x value because it's a standard normal, is the area to the left. You're not given that. You're told the area to the right. So by subtracting the area to the right, 0.4483, from 1, you find the area that you're interested in is 0.5517. So it's an inverse norm. You know the area that you're looking for, mean is 0, standard deviation is 1, and there's your correct answer. Correct at 2 decimal places, 0.13, 13 hundredths. The area that's associated with this value that you don't know is the area to the left. He tells you the area to the right. You have to do subtraction. Number 6, find, let's see, the mean is 60, standard deviation is 4.0. All right, so it's a non-standard normal. All right, what's the probability of x being less than? Well, if it's less than, you're going to the left all the way to negative infinity. All right, negative E99. Your upper limit is just what it says, 53. You mean is 60. The standard deviation is 4. Hit enter, plug it in, hit enter. Spot on, 0.4001. I'm sorry, 0.0401. I can say it correctly. Number 7, human body temperature is normally distributed, mean of 98.2, standard deviation 0.62. Find the temperature that separates the top 7% from the bottom 93. Well, that value is to the left, the bottom, not the bottom portion. We told you the bottom is 0.93. All right, 93%. It's not the 7%. That's the top. That's the area to the right of where you're looking for. You're interested in the area to the left. That's the bottom portion, 0.93, 93%. There's your mean, 98.20. There's your standard deviation, 0.62, and your answer is off by 1/100, 99.11. Correct answer, 99.12. We were getting something even close to that. So 1/100 is pretty darn close. Here, number 8, you're asked to find the 81st percentile. All right, and that separates the bottom 81% from the top 19%. All right, so the value that I'm looking for is found by taking the area to the left. The area to the left, P81, is just that, 0.81, 81%. Mean is 70, standard deviation 11.5. Do your magic here, 80.1, spot on to letter C. All right, central limit theorem. All right, here the standard deviation changes. It's the original standard deviation divided by the square root of how many items you're talking about. Here we know the mean, 9.3, standard deviation 1.1, and we're asked to find the probability that for 70, not 1, but 70 selected washing machines. All right, so there's my end value, 70. So everything is the same. My lower limit, I'm going to the less than, means I'm going all the way to the left, all the way to negative E99. I'm stopping at 9.1. The mean stays exactly the same, 9.3. The standard deviation now becomes the original standard deviation, 1.1, divided by the square root of how many washing machines you're talking about, all right? So central limit theorem, you know that you have to adjust the standard deviation. Reason being is everything is a little closer together. The standard deviation becomes smaller. You make it smaller by taking the original one, dividing by how many, your end value, in this case, 70 different washing machines. Little discrepancy here, but not much, 0.0641. Correct answer, 0.0643. Once again, nothing even close. You're off by 2/10,000ths. We can live with that. The weights of fish in a certain lake are normally distributed. Mean is 13. Standard deviation is 12. If 16 fish, I've even highlighted it. The giveaway is when I say central limit there. All right, all these problems until the directions change deal with central limit. You're not working with one fish. You're working with 16 fishes. So when it comes time, your lower limit is we're looking for the probability of a fish weighing between 10.6 and 16.6. All right, so 10.6 is your low, 16.6 is your upper. Mean doesn't change, it's still 13. However, standard deviation becomes the original standard deviation, 12, divided by the square root of how many, in this case, fish we're talking about. I could have taken the square root of 16, gotten 4, 12 divided by 4. I could have put that in as 3. I mean, that I could have done in my head. I didn't have to have a calculator do this for me, but no harm. And here again, you see your answers off by 1/10,000, 0.6731. Nothing even close to that. All right, now we go to the last section, 6.6, continuity correction, which means you start out by drawing your bell curve. You draw a line, in this case here, that represents 43. 43 has nothing to do with the problem, except that we need to subtract 5/10 from 43 and add 5/10 to 43. 43, 42.5 and 43.5. All right, now we're looking for the probability of more. Well, more means we're going to the right. Now, the question is, do I start at 42.5 or 43.5? He's saying more than 43. So more than 43 would not include 43. So I can't very well start at 42.5 and go to my right because I would include 43. I got to start at 43.5. Number 12, letter A. All right, to the right of 43.5. Probability of fewer than 52. Well, fewer means I'm going to the left. First of all, subtracting 5/10 from 52, I got 51.5. Adding 5/10 to 52, I got 52.5. I'm going to my left. Now, the idea is, does fewer than 52 include 52? Well, no. So I can't very well start at 52.5. I got to start at 51.5 and go to my left. All right. Continuity correction, adding and subtracting, finding out which way you're going, left or right, you're getting bigger or smaller, and then figuring out that, hey, does it include the target value or not? All right, continuity correction, things change here. All right, lower limit doesn't really change, upper limit. What does change is you got to figure out the mean. The mean is n times p, and the standard deviation is the square root of n times p times q. We're talking about rolling a die. So probability of any one number coming up to 6 sides to a die is 1 chance in 6. And we're looking for the probability that in 200 fair tosses we'll get at most 30. At most 30. All right, so 30 is the limit. We're not going above 30. So we're going to the left, all right? 29 is good, and 28, and so forth. We're going to our left. So my lower limit is negative infinity. My upper limit is 30.5. Now, why 30.5? Because I had to take 30. I had to subtract 5/10 and then add 5/10. And then I asked myself, does at most 30 include 30? 30 is good. So I can't very well start at 29.5. I got to start at 30.5. Now, that doesn't agree with at most 30. Don't get all bent out of shape. All right, continuity correction doesn't always agree with what's going on here, but you got to trust continuity correction, meaning you're adding, subtracting 5/10. We know we're getting smaller, and we know at most 30 includes 30. So that's why I'm starting, my upper limit is 30.5, not 29.5. If I started at 29.5, went to my left, I would include 30, and at most 30 includes 30. So don't get bent out of shape, because sometimes continuity correction doesn't agree with what you're reading here, but you got to trust that you're doing it right. All right, there's my lower, there's my upper. The mean is n times p. All right, probability of rolling a 4 is only 1 4 out of 6 faces, so it's 1 chance in 6. Standard deviation is n, 200 times p, which is 1/6. Well, p is 1/6, then q is 1 minus 1/6, or 5/6. Notice you don't need any parentheses here. All right, what you're missing, you don't see here, is the fact that this is the square root. I run out of space when I'm doing it because there's just so much room on the calculator. All right, 0.294, 0.2954. Kind of a huge discrepancy here, but notice, letter D is not even close to 0.29. This is way off, and letter A is ridiculous. So I can live with the fact that I'm off by 9/10,000ths. If I couldn't live with that, I don't know why you couldn't, because there's nothing else even close to the correct answer. I'd have to get involved in z-scores and go to my table and do my subtraction. And there's ways of getting it spot on, but you have to convert to z-scores and use your table. Number 14, estimate the indicated probability of by using normal distribution to the binomial. It's continuity correction. Exactly 33. Well, those are the easy ones, the exact, all right, because You subtract 5/10, get 32.5. Your upper limit is you add 5/10 of 33, 33.5. The mean is n times p because the probability of a boy or a girl is 0.5. All right, and then the standard deviation is the square root of n, which is 90. All right, 90 births times p, probability of a girl, 0.5, times q, which is also 0.5. Right? 1 minus 0.5 gives you q of 0.5. And here's a case where you're spot on, 0.0035, letter C. Product is manufactured in batches of 120. There's your end value. Defect rate is 7%. Probability of for the selected batch containing more than 5. Well, you got 4.5 and 5.5. You're going to your right. And the question is, do you start at 4.5 or 5.5? It says contains more than 5. Well, more than 5 does not include 5. If I started at 4.5 and went to my right, I go right over 5. I would be including it. No, I got to start at 5.5 and go to my right. So my low is 5.5. My upper is infinity. E99, mean is n times p. Tells me what n is. He tells me 7%, 0.07. Square root the standard deviation, square root of n. 120 times p, which is 0.07. Well, if p is 0.07, then q is 1 minus that. 1 minus 0.07 is 0.93. And I like it here because this answer is spot on to the correct answer, letter A. All right, that kind of takes care of that. And you got your exam on the 10th. Just be aware that the 10th is a Monday, all right? And that's the last official day of class. And that's when your final is. Bon chance.